is Athirah. It is my pleasure to present to you my study on the gene expression analysis of signaling pathway associated with collagen type 1 induced osteogenic differentiation of dental pulp stem cells. Let me briefly introduce the background of my study. Do you know that one of 4 major causes of death in Malaysia is the road traffic accident? Which means more people are likely to be killed by traffic accidents rather than chronic illnesses such as cancer or hypertensive disorders. Road traffic accidents contribute the most to the cases of craniofacial injuries in the emergency department. These usually involve young male motorcyclists and can cause long-term effects on their quality of life. In order to address the limitation of standard graft treatment for craniofacial injury, tissue engineering strategy has combined the application of stem cells, growth factors, and scaffolds to improve bone reconstruction and regeneration. In our School of Dental Sciences, almost every day we have the extraction of supernumerary teeth, which are considered as medical waste. Therefore, stem cells from dental pulp can be an accessible and promising source of stem cells for regenerative study. As previously described, scaffold is one of the major components of tissue engineering. Collagen, especially collagen type 1, has been widely used as scaffold material for bone regeneration since it has shown evidence of biocompatibility and also support the growth of bone cells. However, very limited study can be found on the cellular mechanism of osteogenic induction by collagen type 1. Generally, the objective of this study is to identify the signaling pathway in differentiation of dental pulp stem cells into osteoblasts by collagen type 1 induction. The specific objectives are to characterize dental pulp stem cells from mesenchymal markers, to assess the potential osteogenic differentiation of dental pulp stem cells by collagen type 1 induction, and to identify the signaling pathway associated with the process. This is the overview of my research methodology. It starts with the revival of dental pulp stem cells. For the first part of characterization, cells are cultured in standard growth media and osteogenic inductive media to be observed for its mesenchymal stem cells property. Alizarin staining are performed to assess osteogenic differentiation by detecting the calcium deposition. In the second part of this study, optimization of collagen 1 coating on plate are performed to find the best condition of collagen scaffold. We measure the osteogenic differentiation by alizarin staining and the expression of osteogenic gene markers. The last part of inhibition study will be performed by using optimized scaffold. Moving on to the result. Dental pulp stem cells indeed exhibit mesenchymal stem cell characteristics. Cells show typical mesenchymal stem cells morphology, which is spindle fibroblast-like shape. PCR results show that dental pulp stem cells positively express CD73, CD90, and CD105, which are the common mesenchymal stem cell gene markers. Dental pulp stem cells also shows capability to differentiate into bone cells, evident by positive stain for alizarin red after being cultured in osteogenic inductive media for 21 days. For the optimization of collagen scaffold, we tried coating of culture plates with collagen type 1 concentration of 1 and 2 mg per ml. We also tried mixture of collagen 1 with matrigel, which has shown promoted osteogenic induction in previous study by Psy in 2010. Cell cultured on matrigel and cell cultured on plate without scaffold is used as negative control, while cells grown on osteogenic media are used as positive control. Alizarin staining are performed on day 21 after seeding on the different plate coatings. Quantification of alizarin staining shows that collagen 1 at concentration of 2 mg per ml has the highest calcium deposition. To further confirm the best condition of collagen 1 coating for osteogenic induction, we analyzed the gene expression of osteogenic markers osteorex, osteocalcin, and DLS5. Cells are grown on the different plate coatings, and reverse transcript test PCR is performed using RNA extracted on day 21 of seeding. Semi-quantitative analysis of gel band intensity is conducted to compare the level of gene expression. Based on the graph, it is shown that both concentration of collagen type 1 coating has the highest expression of the osteogenic gene markers. In this study, we managed to prove that culture of dental pulp stem cells on collagen 1 scaffold alone can cause spontaneous differentiation of stem cells into osteoblasts. Following up to this outcome, we need to further elucidate the signaling pathway associated with collagen 1 induction process by blocking of pathways, targeting few related pathways such as P13K-AKT, ERK, and BMP SMART pathway. I have come to the end of this slide. I would like to thank everyone who involved directly or indirectly in this study. These are my references. Thank you very much for your attention.